The last shape we're going to talk about for volume is the sphere. We didn't do spheres with surface area. There is a way to find surface area of a sphere. It just wasn't one that we really focused on when we were in that unit. But we are going to include spheres today when we talk about volume. And the formula for the volume of a sphere is just written right up here at the top of your page. It kind of resembles some of the formulas that we've seen for like the cone and the pyramid because they both also were divided by 3. But notice that the top is a little bit different. There's a 4 now in front of the pi, and instead of r being squared, r is raised to the 3rd power. So there are some like minor differences between this formula and the formulas that we've been seeing like last week with our cylinder and our cone and all of that. So make sure when you're working with your sphere that you recognize like you're going to take the radius to the 3rd power today instead of just squaring it, and then we'll have to deal with that 4 as well. But for a sphere, all you need in order to find the volume of it is the radius. Now we'll also talk about hemispheres, because if you notice the title of this section is volume of spheres and hemispheres. What's a hemisphere? Half of a sphere, okay? If you even just think about the Earth, okay? The Earth is a sphere, and it has a hemisphere. We're split into hemispheres, I should say. Like the equator cuts us into 2 parts, okay? You've got the northern hemisphere and the southern hemisphere. When we cut any sphere in half, like if I cut a golf ball in half, if I cut a basketball in half, that would just be considered a hemisphere. So we'll talk about how do you handle situations like that as well. So let's get into some examples here. For the first one, do we have the radius? Yeah, what is it? 3. So I'm just going to plug it into my formula. 4 pi times 3 to the 3rd all over 3. Now, when you're typing this in, especially if you're working with your calculator, be careful that you don't maybe try to do too much at one time, because if you don't know how to type it in correctly, your calculator will not do it correctly. Okay, your calculator can do a lot of things, but it doesn't know order of operations, so it doesn't know how to follow. It's just going to follow what you type in. So for this one, I would take 4 times 3 to the 3rd power. Let's leave pi out of it for right now. And then after you do the numerator, then divide that by 3. You can reduce before if you see anything that you want to simplify. You could do that if you wanted to, but you don't have to. You could just type it in like you see it here. What did you guys get when you did this? Good. 36 would be your number that comes out, and then we have a pi attached to it still, and then still centimeters cubed. Very good. Okay, if you look at number 2, do they give you the radius? No, but could you find it? Yeah. What is the radius of this sphere? Just 5. It's just half of the 10. So again, we're just going to plug 5 in. 4 pi times 5 to the 3rd all over a 3. Again, I would take 4 times 5 to the 3rd power divided by 3. If you're not sure how to type in an exponent of 3, and you could do it the long way and just do 5 times 5 times 5, or most calculators, whether you're using one of mine or if you have your own, should have this button. It kind of looks like an upside down V. It's called the caret key. You can use that to get any exponent. So even in the future, like when you guys go to other classes next year when you're in Algebra 2 and you're dealing with bigger exponents, you could use that key to get any exponent that you want. Okay? What'd you guys get here? Is it 6 repeating, technically?
6 repeating, but it ends with 7.
Okay, I'm going to go ahead and, well, it ends with 7 on your calculator because your calculator is going to round it off for you, but it would continue to go. If my calculator had more screen space, it would keep going 0.66666666 forever, okay? So we're going to do 166.6 repeating pi, and then still centimeters cubed, okay? Or if any of you had it written like this, 500 over 3 pi, I would take that too. The 500 over 3 is where that 166.6 repeating comes from. So if you leave it as a fraction, that does not bother me. I will take either answer. You can give me the fraction form or you can give me the decimal form there. As long as whatever you give me is correct, you're going to be fine. And then make sure you still have pi centimeters cubed. All right, let's go on to number 3 here. What do we have that's kind of making up this shape? We have a cylinder, okay, and then a hemisphere, right? So we need to find the volume of both of those two shapes. We've got a cylinder at the bottom, and then we've got this hemisphere at the top. So let's kind of think back. Let's deal with the cylinder first. So volume of a cylinder. Think back to last week. What did we do for volume of a cylinder?
Times pi r squared times height.
Good. Pi r squared times height is for a full cylinder, okay? So now we're going to plug this in. What is the radius of my cylinder? Is it 3? Or is it the 6? It is just the 6. Now the picture's a little bit weird. Okay, if the 6 was the diameter, they probably would have put it more in the center. Like they would have put it here over that dot to kind of let you know, like we're talking about the whole length here. Kind of like what they did on number 2, where 10 was like in the middle of the picture. When it shifted off to the side like that, I'm going to assume that they're telling me that that's my radius. So my radius would be 6. What's my height? Also 6. How do you know that? Yeah, those dashes are telling you these are equal to each other. So if you wanted to, you could even just put right here, this is 6 centimeters as well. Okay, so now you should be able to do this. What does that simplify out to? Pi, right? I'm not going to worry about labeling it right now because I'm not completely finished. But that, just for the cylinder, comes out to be 216 pi. Now let's talk about the other shape, which we said was a hemisphere. I'm just going to abbreviate that, volume of the hemi here. So let's figure out how to do this. If I was thinking about a full sphere, that would be the formula that we just talked about at the top of your page there. So it'd be 4 pi times the radius. The radius of the hemisphere is still 6. So I would still put 6 in here to the 3rd power. And this is all over a 3. That would be for a full sphere. What do I need to do yet, though? Divide all of that by 2. Okay, you could write that a couple of different ways for yourself. You could do it like this, divide by 2. Or you could put like another bar underneath that, divide by 2 like that, make it a really big complex fraction.
Could you change the 4 to a 2?
I would be careful about doing that, just because if you're taking all of this divided by this, you'd actually be multiplying by the reciprocal, which would be a half. So you'll want to be a little careful. It might still work out that you could take that 2 out. What I would do if I was calculating this is I would just handle everything on the top first. So I would take care of all of this first. So take 4 times 6 to the 3rd divided by 3, get an answer there, and then cut that in half. If you want to rewrite this so it's not like a complex fraction, and then see if you can get rid of that 2 somewhere, that would be fine. What'd you guys get here for just this?
144.
Good, that's what I have written down. So that whole kind of mess of a formula there should simplify out to 144 pi. Now, what do we do to finish? Add them. So we're going to take this 216 up here and this 144. We need to add them together to get the total shape. What is that? So 360 pi and then still centimeters cubed. Very good. There's your total volume. That's one of those composite shapes. We've seen those kind of pop up sporadically. You've seen on other worksheets, like even on the worksheet from Friday over the cones, you had a one that had a cylinder with a cone on top. This is kind of like that, but it's just a cylinder with a sphere on top. So kind of getting more into those composite shapes that we spent some time on last week. All right, we've got one last problem here. We want to find the volume in this can, not including the 2 tennis balls. So I kind of want to figure out like what's left in the can. So all that space on the edges or like the outer sides of those tennis balls, that's what I want to find the volume of. I would need to start to maybe find the volume of the entire can first, like if it was completely empty. So if there were no tennis balls at all, I would want to know what the total volume is here. What shape is the can in? A cylinder. So I'm going to do volume of my cylinder first. Okay, we just talked about this formula before. It was pi radius squared times the height. What's my radius of my cylinder? 9. And what's the height of the cylinder? 26. Okay, so what does this come out to be? Okay, so that would just be for the full can if it was like empty. Okay, but it's not empty. We've got these 2 tennis balls in there. What shape are the tennis balls? What have we been talking about today?
Spheres.
Spheres. Okay, so let's find the volume of one of the balls here. So pi times, 4 pi I should say, times the radius. What's the radius of the sphere? 6 to the third, all over 3. That's for 1. What do I need to represent both of them? Times by 2. So a little bit different than what we did on the last one. The last one we had to divide by 2. This time we're going to multiply by 2 because we're doubling the amount of spheres that we have in our picture here. What does that come out to be? Okay, pi. What should we do with these numbers? This time subtract, because I want to know the rest of the space in the can. So if I take 2,106 minus 576, what's that come out to be?
1,530.
Good. We still have a pi. We still have our label. All right. Do we have any questions on spheres today? Okay.